Back, everyone. We are into a new type of testing. We are now to alternating series. An alternating series is one that has it's flip-flopping, -1, +1, -1, +1. So positive, negative, and so on. Negative, positive, negative, positive. Called an alternating series. And our alternating series test actually isn't too bad. It's actually a relatively simple, straightforward one. Now, it only works with alternating series. I get students occasionally that will try to apply it to something that's not alternating, and that's inappropriate. So let's jump to it. What is the alternating series test? Well, when we have a series like this, and we have a -1 to an n like this, and it could be n-1 to the just to the n +1, all those would be considered alternating series. And then we have our b sub n term. This is the part, or I should say the rest of the sequence that is not alternating. And I'll get to, so for example, this part here, that by itself is the b sub n. In this case, b sub n would be the 1/n. It's just not the alternating part. Now, all of the b sub n terms must be positive. And you can see without the alternating part, when n starts at 1 and then 2 and 3 and 4 and so on, that's going to be positive. Same with this one. Now, two other conditions must be satisfied. It has to be decreasing, and that's what this says, decreasing. Meaning each successive term must be smaller than the previous. So as n gets large, it's getting smaller and smaller and smaller. And the third condition, well, it looks like there's only two here. The first one I'm saying is that these terms have to be positive, has to be decreasing, and this limit has to go to 0. If the limit doesn't go to 0, or if it's not decreasing, all that means is that we cannot use the alternating series test. It does not mean that it's divergent. However, I will say if that limit doesn't go to 0, I would go back to the test for divergence and check that. But all that this says is if the b sub n terms are positive, it's decreasing, and that limit goes to 0, then the series is convergent. So let's do number 1 here. And as I meant, you'll notice it's my example here. B sub n in this case is 1/n. And this is definitely decreasing. And in general, we'll say that the rule for decreasing is if the degree in the bottom is bigger than the degree in the top, then it's going to be decreasing. Meaning the bottom is going to get, the denominator is going to get a lot larger faster than the numerator is, which means the whole thing is getting smaller and decreasing. And we could even write some of them out. So 1 and then 1/2, 1/3, and you can see it's getting smaller and smaller and smaller and smaller. So it's decreasing. All of these terms are positive, and the limit as n goes to infinity of 1/n equals 0. So we've checked all the boxes. Very straightforward, very simple. Therefore, conclusion is -1/n is convergent. Let's do a few more examples. So in this case, b sub n is 3n/4n minus 1. Now, right away, I can see a problem here. And be it decreasing or not, I can see that that limit, as n goes to infinity, of 3n/4n minus 1 is going to be 3/4. I know that because when the degrees of the polynomials are the same, then the lead coefficients take over. Meaning that is not 0. All that this means is we cannot use alternating series test. So we have to pick from the other tests. And like I mentioned before, if that limit doesn't go to 0, let's try the test for divergence. And now that means the whole thing, that limit has to go to 0. So the limit as n goes to infinity of -1 to the n, 3n over 4n minus 1. No problem. Because it's a limit, I can actually break it up like this. And unless this limit goes to 0, this part will never go to 0. And this limit we know goes to 3/4, right? So this limit actually becomes plus or minus 3/4. And the point is, it's not 0, which means it fails the test for divergence. Therefore, is divergent. All right, next up. Example 3. So here we have an alternating series, but it's written out. So let's try to get it into its form. So first of all, it's alternating, -1 to the n. And I want to test that. When n equals 1, it's going to be negative, which that first term is negative. So I'm going to leave it like that. If it wasn't, if it was off, then we would just do a +1 or a -1. It wouldn't matter. Now up top, it looks like 2 times n. When n is 1, we get a 2. When n is 2, we get a 4. When it's 3, we get a 6, or and so on. Over. Now this is looking to me like this is going to be n plus 4. 1 plus 4 is 5. 2 plus 4 is 6. 3 plus 4 is 7, and so on. So I'm getting this, and it looks like my b sub n is going to be 2n over n plus 4. And I can see that the degrees are the same in this case, and right away I can see that that limit is going to be 2. Point is, it's not 0. So again, all we can conclude from this is that we can't use the alternating series test. Once again, try the test for divergence. That's the whole limit. And just like we did with the previous one, we could split it up into 2 separate pieces. I'm not going to, but we can. Times 2n over n plus 4. And that gives us plus or minus 2. The point being, it's not 0. Therefore, we know is divergent. So again, one of the axioms wasn't met, so we couldn't use the alternating series test. So we switched to another test. All right, let's try example 4. Looks like b sub n in this case is the n squared over n cubed plus 1. Now you might be thinking to yourself, hey, why don't I use a comparison test? That kind of looks like n squared over n cubed. If you remember the comparison test, all of the terms, original terms, have to be positive. And that definitely is not true here, right? Or negative then positive, then negative then positive, and so on. So notice the denominator degree is larger than the numerator degree, which means that this is decreasing. And the limit goes to 0. And just like that, we're done. is convergent. It met both axioms there. Right, next up, we have this. It looks like our b sub n is 3n minus 1 over 2n plus 1. And I can see that that limit does not go to 0. So we cannot use alternating series test. But once again, test for divergence comes to the rescue. That's the limit of the whole thing, including the -1. And the point is, this is not 0. So by the test for divergence, this is divergent. All right. Just a few more examples. All right. So for this one, it looks like my b sub n is e to the 2 over n power. I'm going to note that as n gets large, that denominator goes to 0. And e to the 0 power is 1, not 0. So we cannot use the alternating series test. And then the test for divergence. We test the whole thing, including the alternating part. And the point is, it's not 0. All right. Oh, so our conclusion, therefore, is divergent. The test for divergence. All right. So these next two are sort of connected in a sort of way. It looks like b sub n is going to be the sine of pi over n. And is it decreasing? Well, what we can do is we can take a function and yeah, so let's do this. Let's see what we get. First of all, I need to be in radians. I'm in radians. And I'm going to put this into here, sine of pi divided by, let's call it x. And I'm going to evaluate this as n is increasing. So we'll start with n equals 1. Okay, we have 0. Because sine of pi is 0. Let's try 2. Let's try 3. try 4. Let's try 5. Do you see it started at 0, went up to 1, and now it's slowly getting smaller and smaller and smaller. And let's see what happens when we make it really big. Let's make it 50. You see it's getting closer and closer and closer to 0. Let's do it really big. Let's do 500. Yeah. So we're getting closer and closer to 0. So this is definitely decreasing. And the limit as n goes to infinity, sine pi over n. Now that limit goes to 0, and sine of 0 is 0. So this is convergent. So this series is convergent. All right, now let's see if the same thing works for cosine. It won't. My b sub n in this case is going to be the cosine pi over n. And I'm going to take that limit right out of the gate here. And as that n gets large, that whole piece there goes to 0, and cosine of 0 is 1. That is a problem. So we can't use the alternating series test. And once again, test for divergence to the rescue. All right. And so we're going to take the limit of the whole thing. You might be wondering at this point, can't we just know that it's going to do that? We have to run a separate test because test for divergent or alternating series test does not test for divergence in it. It's not in the theorem at all. But this goes to plus or minus 1. That means it's not 0. Therefore, this series is divergent. This is a nice, easy test. Again, it's only able to use it when it is an actual alternating series. Don't try to apply it when it's not. It won't work for you. Thanks.